In exercise 8, we're asked which equation has the same solution as the equation x squared minus 6x minus 12 equals 0. Looking at our choices, it looks like they've all been written in vertex form with a constant added to the right-hand side of the equal sign. We can use completing the square to write our equation in vertex form. We begin by making sure that the original equation equals 0. It does. Now we can begin the process of completing the square. Insert the boxes, take half of the b term and square it. Negative 3 squared is 9. 9 is the number that goes in each of the boxes. Now we can take our equation and write it in vertex form. X minus 3 squared minus 21 equals 0. Add 21 to both sides of the equation so that it matches our choices, and we can see that our equation x minus 3 squared equals 21 is the same as choice 2, and so choice 2 is equivalent to the original equation. There's another way you could approach this problem. Suppose you didn't know how to complete the square or you forgot how to do that. You could take each of the original equations in the choices, set them equal to 0, and replace the 0 with y equals. Now, put that equation in the graph, pull up a table of values, and see which equation has the same table of values. On close inspection, I see that the table for choice 2 has the same table as their original equation did, and so therefore choice 2 in the original equation must be equivalent. Exercise 9 talks about a ball being thrown into the air from the edge of a 48-foot-high cliff. Eventually the ball lands on the ground. The shape of the graph formed by the height of the ball is given by the parabola. They ask us over what interval is the ball's height always decreasing. Where a graph has positive slope, the function is increasing, and where the graph has negative slope, the function is decreasing. It always changes from increasing to decreasing, or vice versa, at a point called the vertex, or the turning point. If we look where the function begins to decrease, we see on the x-axis it happens right about 2.5 seconds. Where does the ball hit the ground? 5.5 seconds, and that's where it ends. And so we say that this function is decreasing over the interval from 2.5 seconds to 5.5 seconds. Remember, whenever you're talking about increasing or decreasing, you're always looking at the interval of the domain, or the x values, to write that interval. In exercise 11, we're asked which of the following choices could be the correlation coefficient of the data shown on the scatter plot. We look at the choices: 1, 0.93, negative 0.93, or negative 1.0. Let's remember what a correlation coefficient is. A correlation coefficient is a number from negative 1 to positive 1 that describes how linear data is. If data has a correlation coefficient of negative 1 or 1, that means it's perfectly linear. If a set of data has a correlation coefficient of 0, then there's no relationship at all, and it's just kind of scattered about randomly. You can see on the sample graphs that the closer the correlation coefficient becomes to 0, the more scattered or the less linear the data becomes, and the closer to 1 or negative 1, the more linear it is. A negative correlation coefficient represents a negatively sloped data, and a positive correlation coefficient represents data that has a positive slope. Let's look at our choices carefully. We notice that choice 1 and choice 4, 1 and negative 1, would mean that we had perfectly linear data. Looking at the scatter plot, we see that the data is not perfectly linear, and so choice 1 and 4 are not the best candidates. How about 2 and 3? Well, we can't ignore the fact that this scatter plot shows data that has a negative slope, or a negative correlation. Since it's not choice 4, the only other negative number is negative 0.93, which means that that must be our answer, choice 3. Of course, you could always take the data points, put them into a list and spreadsheet in your calculator, and perform a linear regression to get the R value, which would be the correlation coefficient. In exercise 12, we're told that Keith determines the zeros of a function to be negative 6 and 5. What could Keith's function be? There's a couple of approaches you could take to solve this problem, and we'll look at both of them. One possible way is to look at the zeros, x equals negative 6, and x equals 5. If we set each of these expressions equal to 0, the factors will be revealed. For instance, adding 6 to both sides shows us x plus 6 equals 0, so x plus 6 is one of Keith's factors. Subtract 5 from x equals 5, and we get x minus 5 equals 0, which means that x minus 5 is one of Keith's factors. The product of those two factors is the function that Keith started with. Close inspection of the choices, compared to our answer, reveals that choice 3 is the correct answer. Another option for this would be to look at each of the functions and find the zeros, determine which one has zeros to be negative 6 and 5. We can do that by setting each of the factors equal to 0 and solving for x. When we do that, we see that choice 3, x minus 5, and x plus 6 give us the zeros of negative 6 and 5. So again, choice 3 is the answer to this problem. In exercise 13, we're given 4 expressions called L, M, N, and P. We're asked which sum represents a result that's a rational number. Let's take a look at the numbers carefully. Square root of 2 does not simplify. 3 square roots of 3 also does not simplify. But the square root of 16 is 4, and the square root of 9 is 3. They're perfect squares. L and M are irrational numbers. N and P are rational numbers. Which sum represents a rational number? When we add L and M, we end up with the square root of 2 plus 3 square roots of 3. That expression doesn't simplify any further, and it has a square root in the answer. It's irrational. Choice 2, M plus N, gives us 3 square roots of 3 plus 4. That radical does not simplify. It's left in the answer, and so we have an irrational number. Choice 3, N plus P, 4 plus 3. 7. 7 is a rational number, 7 over 1. And to be a rational number, it means it simplifies into something that can be written as a fraction or a ratio of integers. 7 is just that. Choice 4, P plus L, gives me 3 plus the square root of 2. That radical doesn't simplify. I'm left with a square root of 2 in my answer, and so that choice is also irrational. That means choice 3 is my answer.